Welcome back. And continuing further into looking into the resources on the HPC cluster. So in the previous video, I just showed you some of the commands using which you can look into what are the different compute nodes are there, what are the partitions are there, what kind of resources in terms of RAM and CPU are available on those particular compute nodes. Going further, what I would like to do in this particular video is trying to give you an idea, one of the ways in which you can access these resources available on these compute nodes. So essentially what we have done in the previous video is we're using SSH and providing the address to the remote server. We establish a connection, and that connection has virtually moved us from our local machine to on the submit node, one of the virtual submit nodes. I'm just simply here saying Xanadu submit external or Xanadu submit internal, but you are basically in one of those virtual nodes from 1 to 5, depending upon whether you ask for the external or you ask for the internal. So now you are on one of these. You are on one of those virtual submit nodes. These submit nodes are not really very powerful machines, especially in case of Xanadu, and it's highly discouraged by the system admin as well as by us that people should not use resources to run any analysis on the submit node, because they're not meant for that particular purpose. The main powerhouse or the main resources for doing the analysis are available on the compute nodes. So the next, in this particular exercise or the next subsequent couple of videos, what I want to show you is how you can, what commands and what the methods in which you can start using the resources on the compute node. So there are two distinct approaches in which you can use these resources on the compute node. One is called the interactive session and another is called the submit batch job. What's the difference between the two? So the interactive session is a session where you type a command, you see the output, you type the next command, then you see the output, and so on and so forth. So every command you type, you wait for the output to be displayed, and then you type the next command. So that's a more like an interactive way. What's how it differs from how the batch job differs. So batch job is like, let's say we have one data set, and when we want to run it through the analysis, and there are 10 different steps through which we would like to run this analysis. So we take our data, run through the first step, whatever the output we get in the first command, we will feed into the second command, so on and so forth. The second goes into the third goes into the fourth, and so on and so forth. Finally, we get the output from the 10th command. So rather than running one command at a time, what we can do is we can write all these 10 commands sequentially into a file. These files are called scripts, and then we can specify in this file, okay, what resources we need, how much RAM, how much memory we would like to use, and then we submit a job. Once you submit the job, then what happens, the resource manager will take your script, and depending upon the resources we have requested, is going to look for those particular resources in the compute node if they are available. Once they are available, then it takes your data in and start running through all those 10 commands in a sequential manner, and you only finally get to see the final output. There is no way you can communicate. Well, you can communicate, but there is no way you can look somehow, you can say, modify an existing command or something. Once you have submitted a script, the control has gone off your hands and everything is going to get executed as described in the script. Whereas in the interactive sessions, you can type a command, can look at the output, and then you type a command and say, okay, the command you just now typed doesn't seem to give you the output you prefer. So you can modify that command and rerun that command with a lesser change in parameters. So that it gives you a flexibility. So why do we prefer interactive sessions and when we would like to use batch job submissions? Interactive sessions are more suitable if you're trying to do some sort of you can say real-time refining of your data. It could be either basically your data set, you are trying to get rid of some issues, you're cleaning it up in some way, or you're trying to generate graphics, so you modify the graphics as required. So that's where you are going to do more of an interactive session. Interactive sessions are also very quite useful if you have trying to test your workflow. So rather than running on your whole data set, the best idea is to subset your initial data set into small file and then run through your, you can say, workflow, one command at a time, go through it, that this goes through every command without getting issues. Where interactive sessions are not useful. Interactive sessions are not useful if your command takes longer time to get executed. So let's say if you're mapping your reads, RNA-seq reads or genome assembly reads to a genome, that process sometimes takes time. It could take 2 hours, could take like 3 hours, depending upon how much data you have. So the interactive session will be busy for 2 hours if you're waiting for it to respond back. That's not really ideal. So in that particular case, it's much better that you submit a batch job, so the system takes care of it. Once the job is submitted, it lets you know that okay, that particular job has finished. In most of the times, if you have a big data sets and you want to run your data through multiple steps, then the batch job submission is the best way. And I'll show you the example of both of those ones. So let's first go and look for starting an interactive session. So interactive session starts with a command called srun. So it's hidden here, but it's srun, srun --pty--p. You specify which partition you would like to use. --qos, this is called quality of services, which is we specify that. You specify memory, how much memory you would like to use in whatever the interactive session you're going to go for. And then how many CPUs you would like to use. That's what you're going to specify, and you're going to say, okay, what kind of session you start. You're going to start a bash session. So going again to each of the flags, --pty is going to start a terminal. -p is going to specify which partition you would like to use. So as I mentioned previously also, these flags actually modify the behavior of the command. The flags is -p is a shorter version, --partition is a longer version. The longer version generally, the way you specify is using this equal to sign and without any spaces on either side. So if you're trying to say --partition, if using the long flag for partition, you're going to say --partition without space equal, without space MCB student. So that's going to be one single continuous string of characters. Here --qos or quality of services is a longer version of the flag. The shorter version is -q. So it's because we are using the longer version, we are using equal to, and then we are specifying the parameter. We could have used the shorter version. In that case, it would have been -q space, no equal to, -q space, and MCB student. --mem is equal to the memory that you need for analysis. The default memory is 128 megabytes, so it's not really adequate for doing any kind of analysis. It's always mandatory to specify memory to start an interactive session. A -c gives you number of CPUs. By default, the system is going to give you one CPU, but if you want to use more CPUs, you can specify more. But if you don't specify -c flag, still by default is going to give you one CPU. The one thing is, what is quality of services is coming back to this particular, which we haven't seen so far. So quality of services is a way in which system admin can provide certain users a preferential access to certain compute nodes. Based on certain policies or other things, we don't want to go into details, but let's say there are some reasons because of which the system admin want to give certain users a preferential access to certain compute nodes, then the quality of services flag that is being used. In Xanadu cluster, we don't have that basically preferential access to any of the compute nodes, but we still have to specify the QoS flag. So let's go back and our basically terminal. I'm already logged into that particular terminal, and I'm on HPC ext3. And here what I want to do is to start an interactive session. So before starting an interactive session, let me use the command host name. That tells us where we are on the system. So it tells me that I'm on a HPC ext3, so one of the virtual submit nodes. So the command for starting interactive session is srun --pty -p. I'm going to specify a particular partition. In this case, I'm going to specify general. I'm going to specify QoS -q. Again, for that one, the QoS is general. --mem equals to 2G is going to give me 2 gigabytes of memory. And then I'm again specify dash C as 1, or if I don't specify also is gonna be fine. There is no uh, yeah, following 1 and there's space between them, and you hit return. Once you hit the return, is going to give you a message that is queued because you submitted a job to the scheduler. It's again you're scheduling a job, because guy asking for the resources is like asking scheduling a request. So your request got scheduled, it's waiting, looking for the resources, and now it has actually scheduled, it basically found that a space for me, and it has now moved me from the submit node to one of the compute nodes. The compute nodes I have moved on is Xanadu 70. If you are not able to see which compute node you have moved to, again type the host name command. That's the best command that will let you know where you are in the system. So now it tells me that I am on Xanadu 70. So I started with one of the submit nodes, which is HPC ext3, and using this interactive session command, I'm now on one of the virtual submit nodes. Not, and I'm on one of the compute nodes. I'm sorry about that. I'm in one of the compute nodes. Now this compute node, as Xanadu 70, has two. What the resource manager has done is given me 2 gigabytes of memory and 1 CPU. In this space I can do whatever I would like to, and I'm not going to affect anybody else. So that's how, and this is here what you can now, you can run, you can do as much interactive commands as possible. You can ask more memory depending upon what kind of processes you are running. So for example, if you're trying to run an R environment here, you can run it, and let's say the R, for example, if you're doing some sort of analysis that needs more amount of memory, you can increase the memory over there, and then basically start a interactive session. So let's say, for example, I wanted 20 gigabytes, but I accidentally typed on 2G, which gave me only 2 gigabytes. So I can come out of this interactive session typing exit, and I can go back using my cursor keys. My previous command is by going up by arrow keys, and if we go my arrow key, it gives me previous command. I can go back, modify this one 20G, hit return, and now my job is now queued, and it's now looking for 1 CPU and 20 gigabytes of memory across all the compute nodes that belongs to general partition. So now it again found, okay, the Xanadu 70 has that resources that I requested for, and that's now the space it has given me on Xanadu 70 has 1 CPU and 20 gigabytes of memory. So I can use this for doing all sort of analysis I would like to in this particular environment. So this is pretty much with respect to, let's say, the interactive sessions. We will look into a little bit more detail about some other commands, less looking into how to look in what are the different softwares on Xanadu cluster and how to access them in the next video.